boys and girls, and welcome back. I wanted to do a video. This is going to cover comparing fractions and how to find a fractional piece of a whole. So let's get started. When we compare fractions, we're trying to figure out which one is larger, smaller, or maybe they're equal to or the same. So there are three different scenarios that can happen when we compare fractions. The first is you're going to have two fractions given to you that they're going to ask you to compare. The first thing you want to do is see if you have the same numerator, okay? And remember that that's the top number, that's the part. If you have the same numerator, there is a rule, but let's figure it out on our own first. We're going to compare 1/3 and 1/6. So a great strategy, as always, is to draw the picture. So I have 1/3 and 1/6. I remind you of my rule. If you want to make a bar, a fractional piece of 3, you're going to draw two lines. You're going to draw one less line than what the denominator is. So draw 2 lines to get thirds, and we'll draw 5 lines to get sixths. All right, so if I shade in 1 of the third, there, and then 1 of the sixth here, I'm easily able to visually tell that this 1/3 is larger or greater than 1/6. Okay? Moving on to this example, 4/9 and 4/5. Again, my numerator's the same, so I drew ninths and I drew fifths. I'm going to shade in 4 of each. And here again, you can easily visually tell that this 4/5 is larger than 4/9. So, a good rule to remember is that which denominator, smaller or larger, and it's, oh, I'm sorry, I did that backwards, didn't I? 4/5 is greater than. The smaller denominator, you'll notice, is larger, okay? And that goes against everything you've ever really thought about numbers. So this one's a little backwards. Whenever you have the same numerator, you're actually going to pick the smaller denominator to be larger of a fraction. Okay, and again, the strategy to use here, since it is kind of a different thinking, is to draw the picture so that you can visually see it. Or you can think about which one is larger, which one is closer to a whole. Okay, so if you had 3 slices of pizza and you ate 1, you ate a lot more pizza than someone who had 6 slices who only ate 1. And again here, 4 is almost 5, right? Remember that a whole would be 5/5. So you're almost right at a whole here with 4/5. So any way you want to think about it, you can draw the picture and shade to compare. You can think about which one's closer to that whole. Or you can use the little rule, which is the backwards thinking. When the numerators are the same, you want to pick the smaller denominator as the larger fraction. All right. Now, when you have the same denominator, it is easy peasy because you're simply looking at the numerator to compare. So here we're going to compare sixths. I have 2/6 and 4/6. So the first thing I'm going to do is use my drawing strategy and shade in 2/6, and then I'm going to shade in 4/6. Okay, visually I can tell that 4/6 is more than or greater than 2/6. Moving down here, we're going to look at eighths, 3/8 versus 6/8. So I will shade in 3/8 and then 6/8. Okay, and it's very easy to tell that the 6/8 is larger than the 3/8. So the rule when you have the same denominator is that the larger numerator is the larger fraction, or the smaller numerator is the smaller fraction. But here you're going to just simply say I have the same denominator, so this is more and this is less, because 4 is more than 2. So this goes along with the logic you've always known with numbers. Alright, what are you going to do when they're both different? Scary. Not really. All right, so first thing you can do, draw it. Again, you could draw fourths and eighths in shade 2 and shade 3 and just visually compare. Or you can use the other strategy and think about which of these is closer to 0, meaning you barely ate anything, which one's the same as a half, and which one's almost the whole thing, okay? But I'm going to teach you the foolproof way, the way that you can really, really figure it out using your multiplication facts. So, you want to ask yourself, when you come to these problems where the numerator is not the same and the denominator is not the same, you're going to want to say, can I turn one of these denominators into the other? Okay? And in this case, if you look at 4 and 8, you have to think about your math facts. 4, which is the smaller number, multiplied by what can get me to 8? Well, 2. So you're going to say 4 times 2 is 8. But what I do down here to the denominator, I have to do to the top, to the numerator. This is a place where sometimes you guys will forget to go and do the numerator, and you're going to compare 2/8 to 3/8, and you're going to be wrong. So be sure that when you multiply the bottom, you always do it to the top. So what do I multiply the top by? The same thing as I multiplied the bottom by. So again, I multiplied by 2 because I want to get my denominators the same. Comparing denominators is much, much easier than the numerators. So 4 times 2 is 8, and 2 times 2 is 4. So now I'm comparing 4/8 to 3/8. And if you remember the rule we just said, when these are the same, all I have to do is compare the value of these numbers. And I know that 4 is more than 3. So 4/8 is greater than 3/8. Okay? Let's do the same thing down here. Can I turn this smaller number of 5 into 10? Yes, I can. Again, all I have to do is multiply it by 2. 5 times 2 is 10. And what I do to the bottom, I do to the top, and I just use the same number. Okay, 2 times 2 is 4 again. So now I have 4/10 compared to 9/10. These are the same, so I just have to compare the value up top, 9 and 4. 9 is more than 4, okay? The other thing, if you use this strategy, 9/10 is almost a whole, right? Because 1 whole would be 10 over 10, and it's almost there, it's only 1 away. Whereas 4/10, I have kind of a long way to go before I get to 10/10. So you can think about it a couple of different ways, but the multiplication will get you there foolproof. Alright, here is a level 4. If you want to think about it this way, you're not going to be tested like this, but just to take you there if you'd like to. This is where you have numerators and denominators are different, but you cannot turn the denominator into itself. So I can't take this 4 and multiply it by something, an even number, and get it 9. Like I could multiply this by a fraction, but we don't want to get into that. So there's no whole number I can multiply 4 by to get 9, is what I'm saying. So what you're going to want to do is take these and basically cross multiply them to each side. So I'm going to take the 4 on this side and multiply this side by that. And I'm going to take the 9 and come over and multiply everything on this side by 9. So it's cross multiplying because I'm taking this denominator and crossing it over and multiplying it to this side, taking this denominator and crossing it over to this side. So 3 times 9 is 27. 9 times 4, 36. 2 times 4 is 8. 9 times 4, 36. So again, the wonderful thing here is I've given myself the same denominator, so I just have to compare these top numbers for their value, and we know that 27 is much more than 8, so it's greater than. Okay, again, I'm going to cross multiply here, times 8 and times 8, and I'm going to cross multiply over here. And again, the reason I'm doing this is because 5 cannot be multiplied by a whole number to get 8. So 6 times 5 is 30. 8 times 5 is 40. 3 times 8 is 24, and 5 times 8 is 40. Same denominator, makes it easy. I just compare these top numbers. 30 is more than 24, so it's greater than. Okay, again, this is not something you need to know right now. It's just something for those of you that want a level 4 to take it further. This is how you cross multiply. All right, and lastly, finding the fractional part of a whole. So if we want to find 1/3 of 12 and we don't want to draw a picture, because you can, it's very, very simple. I'm going to take this number and I'm going to divide it by the denominator of the fraction. 12 divided by 3 is 4. And all I have to do next is multiply it by the numerator, 1. 4 times 1 is 4. So you kind of make a circle around like this by dividing and then multiplying. Okay, 24 divided by 8 is 3. 3 times 1 is 3. So again, this is why, now that we're into fractions, knowing your multiplication and division facts is so, so very important. And lastly, 1/6 of 42 is just 42 divided by 6, which is 7, and 7 times 1 is 7. Right? And here it is again, but this time I did not use numerators of 1. I threw in other numbers. 9 divided by 3 is 3 times the numerator of 2 is 6. So 2/3 of 9, 2/3 of 9 is 6. And then 32, again, divide by 8 is 4 times 3, 12. And 4/7 of 28, I'm going to say 28 divided by 7 is 4 times 4 is 16. Now to put this into a more concrete example, let me show you why you're doing this. If I break this into ninths, 6, 7, I'm dividing by 3 because I want to break this up into 3 equal groups. 1, 2, 3. That's what I just did. I said 9 divided by 3, and I made 3 equal groups. And then I multiplied it by 2, 1, 2, to figure out that that gave me 1, 2, 3, 4, 5, 6 different parts. Okay? So we're going to be doing much, much more of this in class. Use this to help you with homework or to review concepts or terminology. All right?